Get ready, folks, because today we're taking a deep dive into something truly mind-blowing. Black holes.
Yeah, they're pretty incredible, aren't they?
They really capture the imagination, don't they? I mean, these objects are so massive, so dense, that they warp the fabric of space-time itself.
Exactly, and that's what makes them so fascinating, so challenging to our understanding of the universe.
So where do we even begin with something like this? Maybe a good starting point is, how do these cosmic giants even form?
Well, it all starts with the death of a star, a really, really big star. We're talking stars that are at least 20 times more massive than our sun.
Whoa. So our sun is a pretty big deal to us here on Earth, but in the grand scheme of things, it's kind of average.
It is, relatively speaking. When these massive stars reach the end of their lives, they run out of fuel and can no longer support themselves against their own gravity.
So they collapse.
Yeah, they implode, collapsing in on themselves with incredible force. And when that happens, boom, a black hole is born.
Okay, I'm trying to wrap my head around this. So you're saying that something as massive as a star can collapse into a single point?
You got it. A point of infinite density. We call it a singularity.
Singularity. That's a word that gets thrown around a lot, but it's still kind of hard to grasp.
It is. It's a place where all our known laws of physics break down. We're talking about a region of space-time where gravity is so strong that nothing, not even light, can escape.
That's where the whole black part of the black hole comes in, right?
Exactly. No light can escape, so we can't see them directly. They're invisible.
So how do we even know they're there if they're invisible?
Well, we can detect their presence through their effects on the surrounding matter.
What kind of effect?
Think of it this way. Imagine you have a bowling ball on a trampoline. It creates a dip, right?
Pretty big one.
Exactly. And that's kind of like what black holes do to space-time. They warp and distort the fabric of space-time around them.
Okay, I'm starting to get the picture. So the heavier the object, the deeper the dip in the trampoline, or in this case, space-time.
You've got it. And black holes are so incredibly massive that they create these extremely deep dips in space-time. And that's what we experience as gravity.
So gravity isn't really a force, it's a curvature of space-time. Mind-blowing.
Pretty cool, huh?
It is. So this warping of space-time is how we detect black holes, even though we can't see them directly.
That's right. Astronomers look for telltale signs of this warping. For example, they observe stars orbiting incredibly fast around seemingly empty space. Or they see gas and dust swirling around an invisible object, getting superheated and emitting powerful X-rays.
So we're playing cosmic detective, looking for these clues to infer the presence of a black hole.
Exactly. And it's not just about inferring their existence. We're also starting to get a better understanding of the different types of black holes out there.
Different types. I thought a black hole was a black hole.
Turns out they come in different sizes.
Right.
We have stellar mass black holes, which are formed from the collapse of a single massive star.
Okay, those are the ones we were just talking about.
Right. But then we have supermassive black holes. These are millions or even billions of times more massive than our sun.
Billions of times. That's insane.
It is. And what's even more mind-boggling is that we find these supermassive black holes at the centers of almost every galaxy.
Wait a minute. Are you saying that our galaxy, the Milky Way, has a supermassive black hole at its center?
That's exactly what I'm saying.
Whoa. So there's this giant, invisible monster lurking at the heart of our galaxy.
You could say that, but it's not really a monster. It's more like a cosmic anchor holding everything together.
I guess that makes sense. I mean, it takes a lot of gravity to keep a galaxy full of stars from flying apart.
Right. Astronomers have actually been studying this supermassive black hole at the center of our galaxy for decades now. They've even given it a name, Sagittarius A.
Sagittarius A. It sounds kind of ominous.
It does have a certain ring to it, doesn't it? But it's a fascinating object, and as we learn more about it, we're gaining a deeper understanding of how galaxies form and evolve.
So let me get this straight. We have these incredibly dense objects called black holes, formed from the collapse of massive stars. And there's a supermassive one right at the center of our own galaxy.
You got it.
I'm still trying to wrap my head around the idea of something being so massive that it can trap light itself. I mean, what would it even be like to get close to a black hole?
Well, that's where things get really interesting and maybe a little terrifying. Imagine approaching a black hole. As you get closer and closer, the gravitational pull becomes stronger and stronger. You'd start to feel this intense tidal force stretching you out like spaghetti.
Wait, spaghetti? Seriously?
Yeah, it's a phenomenon called spaghettification.
Spaghettification. Catchy name.
It's a bit gruesome, but it gets the point across. The gravity at your feet would be so much stronger than the gravity at your head that you'd be stretched out into a long, thin strand.
Okay, that's officially terrifying. So let's not get too close then.
Definitely a good idea. But even from a safe distance, the effects of a black hole are mind-blowing. Remember how we talked about black holes warping spacetime? Well, that warping becomes so extreme near a black hole that it acts like a giant lens, distorting and twisting the light around it.
So we wouldn't just see darkness.
It's much more bizarre than that. Imagine looking at the stars behind a black hole. Their light will be bent and warped, creating these strange, distorted images.
It sounds like something out of a science fiction movie.
It does, doesn't it? But this is real science. Astronomers have actually captured images of these warped and distorted starlight patterns around black holes.
Wow, that's incredible. So even though we can't see black holes directly, we can see their effects on the surrounding environment. It's like we're seeing their shadow.
Exactly. And those shadows can tell us a lot about the nature of these mysterious objects.
I'm curious, what happens to all the stuff that falls into a black hole? I mean, where does it go?
That's a question that has puzzled scientists for decades. We know that matter is pulled into the black hole and crosses a point of no return called the event horizon.
The event horizon. That sounds ominous.
It is. Once you cross the event horizon, there's no turning back. The gravitational pull is so strong that nothing, not even light, can escape.
So what happens to the matter that crosses the event horizon? Does it just get crushed into oblivion?
We think so. The matter is pulled towards the singularity at the center of the black hole, where it's compressed into an infinitely small point.
Infinitely small. That's just mind-boggling.
It is. It's one of the most extreme and enigmatic phenomena in the universe, and it's something that we're still trying to understand.
This whole deep dive has been a whirlwind of mind-blowing concepts. Black holes, warping space-time, spaghettification, event horizons. It's a lot to take in.
It is, but it's also incredibly exciting. Black holes are one of the most fascinating and challenging areas of research in astrophysics today. And with every new discovery, we're getting closer to unlocking the secrets of these cosmic giants.
It's a reminder that there's still so much we don't know about the universe. But that's what makes it so intriguing, so full of wonder.
Exactly. And who knows what amazing discoveries lie ahead. Maybe one day we'll even be able to peer beyond the event horizon and see what's truly inside a black hole.
Now that would be something.
You know, it's amazing how much our understanding of the universe has changed in just a few centuries. Think about it. For most of human history, we were limited to what we could see with our naked eyes.
It's true. We could only observe the visible light from stars and planets.
Exactly. But then we started to realize that there's so much more to the universe than meets the eye.
You're talking about invisible light, right? All those wavelengths that are beyond the range of human vision.
You got it. It's like we were suddenly given a whole new set of eyes, allowing us to see the universe in a completely different light.
It's mind-blowing to think about all the things happening out there that we were completely oblivious to for centuries. So what kind of invisible light are we talking about?
Well, there's a whole spectrum of it, ranging from radio waves, which have the longest wavelengths, to gamma rays, which have the shortest.
So invisible light includes everything from radio waves to gamma rays. That's a pretty wide range. What kind of things can we see with these different types of light?
It's amazing what we can learn by observing the universe in these different wavelengths. For example, radio telescopes allow us to study the structure of galaxies, map out the distribution of cold gas and dust, and even detect the faint whispers of the Big Bang itself.
The Big Bang. You mean the event that created the universe?
That's the one. By studying the cosmic microwave background radiation, which is a faint afterglow of the Big Bang, we can learn about the conditions that existed in the very early universe.
That's incredible. So radio waves can take us all the way back to the beginning of time. What about the other types of invisible light?
Well, infrared light is great for studying star formation. It allows us to peer through clouds of gas and dust that would otherwise obscure our view. We can see protostars, these baby stars just beginning to form, and we can study the disks of gas and dust that surround them where planets are born.
So infrared light helps us understand how stars and planets are formed. What about ultraviolet light?
Ultraviolet light is emitted by very hot objects, like young stars and active galaxies. By studying ultraviolet emissions, we can learn about the processes that power these energetic objects.
Okay, so we've got radio waves, infrared light, ultraviolet light. What about X-rays and gamma rays? Those sound pretty intense.
They are. X-rays and gamma rays are the most energetic forms of light. They're emitted by some of the most extreme objects in the universe, like black holes, neutron stars, and supernova explosions.
Supernova explosions. Those are the massive explosions that mark the death of a star, right?
Exactly. By studying X-rays and gamma rays from supernovae, we can learn about the elements that are created in these explosions and how they're dispersed throughout the galaxy.
So each type of invisible light gives us a different window into the universe, revealing different aspects of its structure, evolution, and the processes that drive it.
You got it. It's like we're putting together a giant jigsaw puzzle, and each piece of the puzzle represents a different part of the electromagnetic spectrum.
And by combining observations from all these different wavelengths, we can build a more complete and detailed picture of the cosmos.
Precisely. It's a reminder that there's so much more to the universe than what we can see with our eyes alone.
And that there's still so much more to discover. I mean, we've only just begun to explore the universe in these invisible wavelengths. Who knows what amazing things we'll find as we continue to push the boundaries of our technology and our understanding.
That's what makes it so exciting. There's always something new to learn, something new to discover. And with each new discovery, we gain a deeper appreciation for the beauty, complexity, and sheer vastness of the universe we live in.
Speaking of vastness, one of the most mind-boggling discoveries in recent decades has been the realization that our galaxy is teeming with planets. We're not just talking about the familiar planets in our solar system, but planets orbiting other stars. We call them exoplanets.
Ah, yes, exoplanets. They've completely revolutionized our understanding of planetary systems. It used to be that we only knew of the planets in our own solar system, but now we know of thousands of planets orbiting other stars.
Thousands. That's incredible. It seems like every time I turn around, astronomers are announcing the discovery of new exoplanets. How do they even find these planets? I mean, they must be incredibly faint and difficult to see directly.
You're right, most exoplanets are too faint and too close to their host stars to be observed directly. So astronomers have developed some ingenious techniques to detect them indirectly.
Indirectly, what do you mean?
Well, one way is to look for the wobble of a star caused by the gravitational pull of an orbiting planet. It's a very subtle effect, but sensitive instruments can detect it.
So we're not actually seeing the planet itself, but we're seeing the effect it has on its star.
Exactly. Another way to find exoplanets is to look for the slight dip in a star's brightness as a planet passes in front of it, blocking a tiny fraction of its light.
It's amazing how much information we can glean from these subtle variations in starlight.
It is. And as our technology improves, we're becoming more and more adept at finding these hidden worlds.
So tell me about the exoplanets we found. What kind of worlds are out there?
We found a truly astonishing diversity of planets. There are gas giants larger than Jupiter, rocky planets smaller than Earth, and everything in between. Some planets orbit their stars so closely that their years last only a few days, while others have orbits that take centuries.
It seems like there's no limit to the variety of planetary systems out there.
It's humbling, isn't it? It really challenges our preconceived notions about what a planetary system should look like.
And of course, the big question on everyone's mind is, are there any planets out there that could support life?
That's the ultimate goal of exoplanet research. We're looking for planets that are in the habitable zone of their stars, where temperatures are just right for liquid water to exist on the surface.
Liquid water being a key ingredient for life as we know it.
Exactly. And we're finding more and more planets that fall into this habitable zone. Of course, just because a planet is in the habitable zone doesn't guarantee that it's actually habitable. There are many other factors that come into play, like the planet's atmosphere, its magnetic field, and whether it has a stable climate.
So it's a complex puzzle, but we're starting to piece together the clues.
We are, and the pace of discovery is accelerating. With new telescopes and instruments coming online all the time, I'm confident that we'll be making some truly groundbreaking discoveries in the years to come.
I can't wait to see what we find.
You know, as we explore the universe and ponder these mind-boggling concepts, sometimes it's good to bring things back down to Earth, or at least closer to home, right?
Absolutely. We've been talking about black holes, invisible light, distant planets around other stars. It's easy to forget that we have a whole solar system right here, full of fascinating objects and mysteries.
Right. And while we're looking for life on other planets, it's important to remember that our own solar system is a pretty amazing place. It's a dynamic environment full of diverse planets, moons, asteroids, comets. It's like a mini universe right in our backyard.
And even though we've been studying it for centuries, there's still so much we don't know about our own solar system.
That's right. Every time we send a probe or a spacecraft out there, we seem to discover something new and unexpected.
It's true. It makes you realize how much there still is to explore, even right here in our own cosmic neighborhood. So, what are some of the things that we're learning about our solar system that are particularly exciting to you?
Well, I'm really fascinated by the smaller objects in our solar system, the asteroids and comets. They're like time capsules, remnants from the early days of the solar system, billions of years ago.
Right. They hold clues to how the solar system formed and evolved.
Exactly. And they can tell us a lot about the conditions that existed in the early solar system, which might even have implications for the origins of life.
So, you're saying that these seemingly insignificant chunks of rock and ice could hold the secrets to some of the biggest questions about our existence.
It's definitely a possibility. Take asteroids, for example. We used to think of them as just these inert lumps of rock, but now we're realizing that they're much more dynamic and diverse than we thought. Some asteroids contain water ice, which could have been a source of water for the early Earth. Others are rich in metals, which could be valuable resources for future space exploration.
Oh, wow. So asteroids could be more than just scientific curiosities. They could actually be useful for us in the future.
Exactly. And then there are comets, those icy wanderers that swing in from the outer reaches of the solar system. They're like cosmic messengers, bringing us material from the coldest, darkest corners of our solar system.
And they put on quite a show when they get close to the sun
Mhm.
with those long, glowing tails.
Right. That tail is actually formed when the sun's heat vaporizes the ice in the comet, creating a cloud of gas and dust that streams out behind it.
It's amazing how something so small can create such a dramatic display.
It is. And comets are not just beautiful to look at, they can also be dangerous.
Dangerous. How so?
Well, if a comet were to collide with Earth, it could cause widespread devastation. That's why astronomers are constantly monitoring the skies, looking for potentially hazardous comets and asteroids.
Okay, that's a little unsettling. But I guess it's good to know that someone is keeping an eye out for us.
It is, and it's not just about protecting Earth from collisions. Studying asteroids and comets can also help us understand the processes that shape our solar system and the potential threats that exist out there in space.
It's a reminder that our solar system is not a static place. It's a dynamic and evolving environment, full of both beauty and danger.
Exactly. And it's up to us to explore it, study it, and learn as much as we can about our cosmic neighborhood.
And that exploration takes many forms, right? From sending robotic probes to distant planets to actually sending humans beyond Earth.
Right. Human space exploration is an essential part of our quest to understand the universe and our place within it. It's about pushing the boundaries of human ingenuity and endurance and inspiring future generations to dream big and reach for the stars.
I love that. Reaching for the stars. It's a reminder that no matter how much we learn about the universe, there's always more to discover.
Exactly. And that's what makes it so exciting. The universe is full of endless possibilities, and I can't wait to see what we discover next.
Well, on that note, I think we've reached the end of our deep dive. It's been an incredible journey exploring the mysteries of black holes, the wonders of invisible light, the diversity of exoplanets, and the amazing discoveries happening right here in our own solar system.
It has been a fascinating exploration, and I hope it's sparked a sense of wonder and curiosity in our listeners.
I'm sure it has.
Mhm.
And to all our listeners out there, keep looking up at the night sky, keep asking questions, and never stop exploring. The universe is waiting for you.